Hi everyone, this video discusses LCM or LCD, least common multiple or least common denominator, for rational expressions. Those are fractions where the numerator and denominator are polynomials. I'll use the examples 1 over x, x plus 2 over x squared plus 3x, 4 over xy squared plus 2 over x squared y, x over x squared plus 5x plus 6 minus 2 over x squared plus 3x plus 2. The key is LCD, least common denominator. In a previous video I showed 3 ways to find LCD using a basic fraction example, including the way I'll use here, so feel free to review that previous video if needed. So example 1, write with LCD 1 over x, x plus 2 over x squared plus 3x. My denominators are x and x squared plus 3x, and I need their LCM, least common multiple. X has only itself as a factor. X squared plus 3x has factorization x times x plus 3. So its factors are x and x plus 3. Now I create my LCM. I need to include every factor but no extra copies. X needs to be in there. Now I need 1x, already have one, and 1x plus 3. So the LCM equals x times x plus 3. It's actually great to leave the LCM in this factored form. Very recommended to leave it like this. To change 1 over x into a fraction with this LCD, I have to multiply by x plus 3 on bottom, so I have to multiply by the same thing on top. My second fraction already has the right format. Example 2, we're going to add 4 over xy squared plus 2 over x squared y. Before I can add fractions, I need an LCD. The factors of xy squared are x times y, and the factors of x squared y are x times y. Now I create my LCM. I need to include every factor, but no extra copies. So LCM, I need an x and 2 y's. Next, I need an x, got it. Another x, and a y, got it. So my LCM has factors x times y equals x squared y squared. Now I make equivalent fractions with the LCD. 4 over xy squared multiply by x multiply by x multiply by y multiply by y. finally I add. That means I total up the numerators and keep my common denominator. Example 3, subtract x over x squared plus 5x plus 6 minus 2 over x squared plus 3x plus 2. Before I can subtract fractions, I need an LCD. The factors of x squared plus 5x plus 6 are x plus 2 and x plus 3. The factors of x squared plus 3x plus 2 are x plus 2 and x plus 1. Now I create my LCM. I need to include every factor but no extra copies. So LCM, I need an x plus 2 and an x plus 3. Next, I need an x plus 2, got it, and an x plus 1. So my LCM has factors x plus 2, x plus 3, x plus 1. Again, it's great to leave the LCM in factored form. Very recommended to leave it like this. Now I make equivalent fractions with that LCD. Finally, I subtract. That means I subtract the numerators and I keep my common denominator. X times x plus 1 minus 2 times x plus 3 all over x plus 2 times x plus 3 times x plus 1. In this case, I need to keep going since I can combine like terms in the numerator. I'll multiply out the numerator and see what I can combine. X squared plus x minus 2x minus 6. 2x plus 6. This is a really big hot spot for errors, this minus sign. I need to make sure it gets distributed to all the terms I'm subtracting. I have x squared minus x minus 6 over x plus 2 times x plus 3 times x plus 1. Now we always want to reduce our fractions to lowest terms. We need to check if there's a common factor to cancel out in the top and the bottom. I'm canceling out at the very end of the problem. You'll want to avoid canceling out too soon. Looking for common factors, so I need to factor my final numerator. Finally, my answer is x minus 3 over x plus 3 times x plus 1. Here's a summary of steps for adding or subtracting rational expressions. 1, we always need a common denominator. Factor each denominator to get started. 2, leave the common denominator in factored form and add or subtract your adjusted numerators. So leave LCD in factored form. Number 3, slow down and watch the minus sign carefully if you're subtracting. And number 4, check if the final answer can be reduced by canceling common factors. This means you'll need to factor the numerator.